4.4, number 170. It says, show there is no value C such that, and again it's the mean value theorem, such that f of 1 minus f of negative 1 equals f prime of c times 2. And then explain why the mean value theorem does not apply on negative 1, 1. Mean value theorem does not apply on the interval they gave us, negative 1, 1. Which you could figure out the interval anyway because of these two values here. This is just f of b minus f of a. So again, this should be a and b, like that. Okay. All right. So the function they give us is a very special function. It's f of x equals the floor function, which is denoted by those bracketed symbols enclosing an x. Now, let us quickly graph part of this and show why the mean value theorem will not apply. All right, there's 1, 0, negative 1. That's our interval right there, negative 1 to 1, they said. Again, you can tell from here. There's 1 and there's negative 1. Okay, the floor function is such that, for instance, if I put in 0.5 in here, the floor function is going to take me down to the number 0, the largest integer less than 0.5. So for all the values between 0 and 1, except for 1, all the values between 0 and 1, excluding 1 itself, all those values along this interval of x will map down to 0 itself, a height of 0. So therefore 0 itself is 0, and then all the values past that on the x-axis get mapped down to a 0 value, so up until here. Now once I'm at 1, right, it's a hole down there. Once I'm at 1, if I plug in 1 into this, I'll get out 1, so it jumps now suddenly. And for any value past 1 until 2, not including 2, like 1.5, 1.4, or whatever, something like that, it's going to map down. For all those values past here, it's going to map up to, I should say, up to 1. So until I get to 2. Once I get to 2, it's going to jump again. Up here, now the same thing over again. Right, 2.1, 2.2, right, along the x-axis, 2.1, 2.2, and so forth up until 3. All those values map up to a height of 2. All right, so there's the basic structure of this function as a graph. That's why it's also called a step function. The greatest integer less than or equal to x also does the same thing. It looks a little different. It's called the ceiling function. It's very similar. All right, so down here we have the same effect right there, and that's not really all we need is to there. But I'll just draw one more open hole there and filled in there, and so forth forever in both directions. And there's our floor function, this particular step function. So on the interval negative 1 to 1, negative 1 to 1 here, let's see, what value is this derivative supposed to take on? All right. Well, f of 1 minus f of negative 1, right, is nothing other than the floor of 1, that's the function we're talking about, minus the floor of negative 1. That's equal to f prime c times 2. And this 2 is not really as arbitrary as it looks, right? It's really the b minus a value, right, which in this case is 1 minus negative 1. It's where they're getting this 2 value from. Okay? So if I calculate this and divide off by 2, right, the floor of 1 is, of course, 1, and the floor of negative 1 is also itself negative 1. Anytime you put an integer in the floor function, you get the same integer back out again. So we get 1 minus negative 1 is 2. And if we divide off by 2, I have 2 over 2 should equal f prime of c. So therefore, the derivative, according to the mean value theorem, if it applied, would be showing us that there's a slope of 1 for some value along here. But you can see that all the slopes are always 0. Right? They're just horizontal segments. Every slope is 0. So there's no way that this derivative of whatever the derivative is, we're not able to write it out as a rule, but you can see from the picture here that all the slopes of the floor function are always 0 or non-existent, no matter where you go. So there is no c, right? That f prime of c would equal 1. The floor function has slope 0 everywhere the slope is defined. So therefore, f prime of c cannot equal 1. Okay? So why did this happen? You would answer because it's discontinuous, right? The mean value theorem requires continuity on the interval. We don't have continuity. We have a discontinuity here happening at 0, and so therefore the mean value theorem does not apply for this function on this interval.